Hello students, welcome to the second part of these problems. So today we will be doing the problems on slant loads or loads inclined. The problems which we solved earlier, the load was exactly vertical. Now we will consider inclined loads. So statement of the problem would be determine the size of the weld required for the bracket connection shown. Load given is 100 kilonewtons. It is inclined at an angle of 50 degrees. So these are the weld details. This is 220 mm, 450 mm. So to find the size of the weld required. Now since this is an design problem, you have to consider factored loads. So we'll start with the solution. Factored load is equal to 1.5 into 100, 150 kilonewtons. The load is inclined load. So we have to resolve that load along horizontal and vertical. This is 150 kilonewton load. So this I am going to resolve along horizontal and vertical. Theta is given as 50 degrees. So its resolution along horizontal would be 150 cos 50 degrees, and that gives me value 96.41 kilonewtons. Vertical resolution will be 150 sin 50 degrees. So that will give me 114.9 kilonewtons. Now let me draw a diagram showing only the weld details. So this will be an enlarged picture. Say this is the weld portion. The load acting. So I am going to substitute only horizontal and vertical loads. So this is 96.41. This is 114.9. Let me write the dimensions. This is 250 kilonewtons mm's. This should be given here in the given problem itself. 250 mm. This is 220. This dimension is 450. Before we start solving, first always mark the CG points, CG of these each of the elements. Let this be element 1. Its CG is at the center. This is 220 at 110 from each of the sides. So similarly for section 3. Now for the vertical element, CG will be at the center. 450, 225, 225. CG will be at the center. Now let us mark the CG axis. Now if you look at X axis, I can mark X axis here. This section is symmetrical about X. Now I need to identify Y axis, the location of CG axis. Let me take the reference plane 1, 1. So I will be finding the distance of CG with respect to reference plane 1, 1. Next. Location of y axis. X bar is equal to a1 x1 plus a2 x2 divided by a1 plus a2. This is in case of two elements. If there are three elements, I will write a1 a2 a3 a2 x2 a3 x3 divided by a1 plus a2 plus a3. Now let me write it for this case. For element 1, area is 220 into t. This thickness is t. 220 into t. X is distance of CG of element 1, this point from reference plane. This hole is 220. Distance of this point from 1 it will be 110. Now if you look at this diagram, element 1 and 3 are same. So I am going to multiply this by 2 plus element 2 450 into t. Now if you look at this element, CG of this element coincides with 1. So distance is 0. Whole divided by 2 into 220t plus 450t. X bar, we get the value 54.38 mm. Now next step would be to calculate moment. Moment m is equal to P into E. So let me mark the CG line on this diagram. Y. X bar 54.38. Now this distance from here to here, this will be 220 minus 54.38, 165.21. Now I have to find moment generated because of these two forces at CG point. Now if you look at this diagram, this 114 produces clockwise moment and 96.41 produce anti-clockwise. So one I have to consider positive, another as negative. Now let me start writing the equation. Moment m, okay, because of vertical load. So load is 114.91 into 10 raised to 3 newtons. This load, perpendicular distance of this load from this axis. So I will require this distance, and that distance is, so this distance is 165.62 plus 250, 415.62. So this will be 415.62 minus this produces, this 96.41 produces anti-clockwise. So I am going to make it minus this into perpendicular distance from here till here. This distance is 225 mm. So minus 96.41 into 10 raised to 3 into 225. I get the answer 26.06 into 10 raised to 6 Newton mm. Next will be to calculate polar moment of inertia. Let me start with Ix. So moment of inertia of this section along X. So this is another diagram which I have drawn for my reference. Along X. So first let me start with moment 1. So dimension parallel to X is B, perpendicular is D. For element 1, B will be 220 into T cube divided by 12 plus area 220 into T into perpendicular distance, area into distance square. So distance of this from X is 225 bracket square. Like this there are two elements 1 and 2. So I am going to multiply this by 2 plus, come to the second element, T into 450 cube by 12 plus T into 450. Perpendicular distance will be 0. Ignore T3, so that becomes 0. So Ixx, I get the value 29.86 into 10 raised to 6 T. Next, calculation of Iyy. Iyy is equal to, first element 1, the B is 2 T, D is 220 divided by 12 plus T into 220, 165 minus 165.62 minus 1110 square plus 450 into T cube by 12 plus 450 into T. Perpendicular distance is 54.38 square. If you look at this diagram for element 1, when I am going to find CG along YY, this is the perpendicular distance. So this hole is 110. From here to here, this is 165. This is 110. 165 minus 110, I will be left with this value. So similarly for element 2, this x bar is the distance, 54.38. So Iyy, I get the value 4.46 into 10 raised to 6 T. Polar moment IP is equal to Ixx plus Iyy is equal to 34.26 into 10 raised to 6 T. Now I have to find each of the individual forces. Let me draw diagram of the farthest point. If you look at this diagram, this is the farthest point. This is the CG. Rx1 opposite to this, Rx2, Ry1, Ry2. Ry1 is opposite to this direction. Let this be resultant R. This is R, this is X, this is Y. Next, vertical direct force Ry1 is equal to vertical force divided by L into T. So vertical force is 114.6 into 10 raised to 3 divided by 890 into T. So I get 129.1 divided by T. So similarly, horizontal direct force Rx1 is equal to horizontal force divided by L into T. So horizontal force is 96.41 into 10 raised to 3 divided by L into T, 890 into T. So I get the value 108.3 divided by T. Next, horizontal force due to moment Rx2 is equal to M into Y divided by IP. Have a look at this diagram. Moment I want to calculate Ry1, sorry, Rx2, this value. Force developed at CG point because of Rx2. So Rx2 is moment M into Y, this distance, divided by IP. So here I get the value 26.06 into 10 raised to 6 into 225 divided by 34.32 into 10 raised to 6 T. So I get the value 170.8 by T. Similarly, vertical force due to moment Ry2 is equal to m into x divided by Ip. So that is 26.06 into 10 raised to 6 T into, so x value is 165.6 divided by 34.32 into 10 raised to 6 T. Ry2 I get the value 125.7 by T. Net force is Rx is equal to Rx1 plus Rx2. Rx is equal to 279.13 divided by 2. Ry is equal to Ry1 plus Ry2. So Ry is equal to 254.8 divided by T. Add Rx1 and Ry1. Now resultant R. Resultant R is given by under root Rx square plus Ry square, and this should be less than or equal to characteristic